Hi, so this is the second question, question number 2 from M2 Jan 2014, and this is from Edexcel Board International A-Levels. So let's get into it. The question is that particle P moves on the x-axis. At time t seconds, the velocity of P is v meters per second, in the direction of x increasing, where v is this. When t equals 0, P is at the origin O. And in the first part, they're asking us to find the acceleration of P when t equals 3. Now to find the acceleration, first we need to find the formula which gives acceleration, and that we can find by differentiating v, because A is given by the rate of change of velocity, which is dv dt. We can do that we could either use the product rule, because we have t minus 2 and 3t minus 10, two different functions of t, or we could expand this and differentiate it. I'm going to use the product rule, and for that we're going to have t minus 2 times 3. 3 is the derivative of the second bracket, plus 3t minus 10 times the derivative of the first bracket, which is 1. And when we expand this, we get 3t minus 6 plus 3t minus 10. And that gives us acceleration equals, actually, 6t minus 16. Now, they're asking us to find the acceleration of P when t equals 3. So when t equals 3, we're going to substitute the value of t in here, and therefore A will be 6 times 3 minus 16, which gives us the acceleration as 2 meters per second squared. Yep. Now moving on to the next part, part B. In B, they're asking us find the total distance traveled by P in the first 3 seconds of its motion. Now we know that to find the distance or displacement, we have to integrate the function of v. So for that, what we're going to do is I'm going to say that displacement is s. So displacement is given by the integral of v with respect to t. I'm going to write the expanded version of v in here just to make things easier. So it's going to be 3t squared minus 16t plus 20 with respect to t. Now when I integrate this, I get, let me do it on this side. Yeah, so it's going to be t cubed, 3t cubed over 3 minus 16t squared over 2 plus 20t plus the constant of integration. Now, when I solve this further, I can cancel this, I can cancel these. So it gives me t cubed minus 8t squared. Sorry, this is 8 actually. Yep. Minus 8t squared plus 20t plus c. Now, here they have told us in the question that when t equals 0, P is at the origin O, which means that when t equals 0, s, which is the displacement from the origin, is also 0. And therefore, c equals 0. And so we can simplify this and write it down as s equals t cubed minus 8t squared plus 20t. That's it. Now, we need to find the total distance traveled by P. And for the distance, it can be anything. Maybe it came and returned back. So we have to find the distance every second to make sure that it to make sure that it's traveling in the same direction, or maybe it reverses its directions. So for that, what we're going to do is when t equals 1, we need to find what s is when t equals 1. So the displacement at that time is 13. And when t equals 2, the displacement is 16. And when t equals 3, the displacement is 15. Now look, there is the displacement at t equals 3 is actually less than the displacement at t equals 2, which means that p went and came back, and at t equals 2 it was here, and at t equals 3 it's here. And the distance that it traveled until here, like until the time was 2, it was 16. And this distance, this displacement from the origin is 15. So which tells us that the distance that it returned after t equals 2 was 1, this one. And to find the total distance, not the displacement, we have to add the total distance that it has traveled, and we can say that the distance, total distance therefore equals 16, which is this, plus 1, which is this. So the total, actually it's 1, okay? So the total distance is 17 meters.